with the chapter vectors. So I am just revising and putting videos. So I don't care if you subscribe or like or do anything or not. I don't care even if you dislike. But you should like and you should comment on this. And I am just revising this. So since I don't want you to waste any of your time here, I want that you stay here only if you want to revise and don't want to and you don't want to read it from scratch or study it from scratch. It is vector quantities. I am also revising right now here. So there are two types of physical quantities: vector quantities and scalar quantities. Vector quantities are those quantities which have magnitude and direction, and the most important thing is they should be added using vector law of addition. And another quantity are scalar quantities which have only magnitude, and they are just normally added and subtracted algebraically. So the best example that separates everything, that marks the clear boundary between vectors and scalar, although it is a tensor quantity, but current is used to tell you that what is the difference between vectors and scalars really. So if let's say for example I am getting a bit more than needed fundamental here, but let's go. If one wire is carrying some current from here and some current from here, and it is going like that, if it's, let's say it's 3 ampere and this is 4 ampere, this will go 7 ampere in here. So you have to just add it, and now let us change the direction of wires. So now current is coming from here and here, and same 4 ampere current, 3 ampere current, and 7 ampere current. So you are saying here that since charge is conserved, so per unit time the equal number of charge is coming from here and coming from here also. So since charge is conserved, it is 7 ampere, means 7 coulombs per second charge is going here, 3 coulombs from here and 4 coulombs from here. We are just algebraically adding both. 4 plus 3 is equal to 7. But in case of, let's say, displacement, here displacement is like this. Let's say a body moved from here, then here. The displacement will be this. And if a body moved from here and here, the displacement will be that. Let's say it is 3 meter, 4 meter, then it will be 5 meter, because I have made it is not perfect, but I have tried to make it perfect 90 degree. And let's say this is 3 meter, this is 4 meter. We know that it is not it is something else, but it is definitely lesser than 5, lesser than 5, right? So it is, this one is, let's say this is A and this is lesser than 5 meters. So vector addition is different from scalar addition. Now let us talk about how to add vectors, and that is where our topic starts. Vector addition. So vector additions and subtraction are very easy topics. There are several laws given on vector addition and subtraction. But before that, before adding vector, let us talk about illustration of vector. So illustration of vector is nothing. I am not going too deep here. Just mark a vector along the direction. So that this part is called the tail, and that part is called head, the opposite part. The direction in which the head part points out is the direction of the vector from tail to head, right? And if in a Cartesian plane, or if on a paper we mark 1 centimeter as 1 unit, like if we are talking about force is a vector quantity, right? So if we are talking about force and 1 unit, like 1 centimeter is equal to 1 newton, then if we have to describe 5 centimeter, we have to make a line which is if we have to describe 5 newton, sorry, we will have to make a line which is 5 times this. Okay, so it will be something like this. Assume my writing is accurate. So this way a vector is illustrated, right? So illustrate this is how we illustrated a vector. Now you know that since a vector of magnitude 1 in any direction can be used in this way, like 1 vector, this is a vector, let's say a vector, and the magnitude is 1. So any vector in this direction, let's say this is 45 degree, or yes, 45 degree, this looks more like 45 degree than 60 or 30. So let's say if any, we have to represent any other vector which is 3 times this, and which has a magnitude of 3 but have the same direction, what we will do, we can just write 3 into a vector. Why? Because it will be nothing but the magnitude of this multiplied by 3, which is nothing but the length of this 3 times, right? So 3 times of this length, 3 times. So when we are multiplying a scalar quantity, like not a scalar quantity, we are multiplying, yes, a scalar quantity, right? So if we are multiplying 3 with a vector, what is getting affected here? Only magnitude is getting affected, and the direction is same, right? Is same. Like this is a vector, it is 45 degrees from horizontal. If some b vector is 3 times, then b vector is also b vector is also 45 degrees from horizontal, then we can write b vector is equal to a vector into 3, right? So if we multiply it, if we generalize this, then if a vector is equal to n times b vector, where n is real number, then a vector and b vector are in same direction. Now, like we saw that we have to multiply the magnitude into the vector having the magnitude as 1. Like vectors having magnitude as 1 are the vectors which have only direction, like they have magnitude 1, but it is pretty much only direction, because this is used in this way. Like those vectors which have magnitude 1, it is called, they are called unit vectors, right? So magnitude into the unit vector, we can call it completely as a vector. So if we will see the above example, here a vector was nothing but the unit vector, right? So a vector was nothing but unit vector, and b vector was 3 times the unit vector. So 3 was the magnitude and a was the direction. So in more generalized way, we represent unit vector, like if vector a was unit vector, we we put a cap like symbol above it. So this is a vector, unit a vector. This has magnitude 1 and direction whatever. So we saw this thing. So just putting the magnitude here, we get unit vectors, or direction of a vector is given by vector divided by its magnitude. Now for rest of our life, let us take a general vector, vector a, right? So vector a, so the direction of vector a will be represented as a cap, and a cap will be equal to vector a divided by its magnitude, right? Magnitude of a, and magnitude of a is also written as a, right? So this is the thing. So we generally, let's move forward with triangle law and parallelogram law, and we will come to the concept of unit vector after some time. So the thing is, in different places they teach you about parallelogram law and triangle law separately and in a very different manner, but in FIITJEE it was different. Sorry, it was KIITJEE, it was different, right? So yeah, so before that we have borrowed 2 formulas from SOT chapter, solution of triangle chapters, right? So let us write those formulas. This is a triangle A, B and C. So this will be the length of this side A, and the side opposite to C will be C, and the side opposite to B will be B. Then let's mark this angle. So according to this sine rule, this is called sine rule. A by sine A, the ratio of A length sine A is equal to B by sine B is equal to C by sine C. These two for another formula. This is sine rule. This formula, and there is one another formula, cosine rule. That cosine rule will also be very effective. Cosine, and we will use it multiple times. Not multiple times, I think a couple of times. We will use it a couple of times for vectors, and for rest of the chapters we will use it many times. But yeah, so cosine rule, and then cosine rule was, again drawing a vector. Now I want to change the color. Let's say this is, then this is A, this is B, this is C, and this is A, C, B. Now I'm not putting the arrows because you know what it is. Then cos A is equal to, I have also read it for the first time in this class 11, so I am just remembering it, so it can be wrong, but yeah, it was A square minus B square minus C square by 2 into B into C. Let me check once if I am correct or if I am wrong. I am absolutely wrong, right? It is just the negative of that. So I don't know why I am even continuing this live, but yeah, the point of making this video was to revise only. So yeah, cos of A is equal to B square plus C square minus A squared divided by 2BC. Right? Now this is cos A, so in similar way cos B will be A square plus C square minus B square by 2BC. Even I have derived these things, then also I am getting wrong, so shame on me. Well, let's go forward. I don't think I have to write sin C. Now let us go on to find out the parallelogram law and the triangle law. So basically both are the same things, only the illustration is different, but yep, I will tell you both. So I won't tell you the definition, or let's say there is one vector like this and another vector like this. Let's say let us name as this as A then B. Then resultant of A to the B will be like this. This is R vector. So what just happened is A vector, B vector, R vector. Let's say a body started from point this to point this and then traveled till this, and so the net displacement will be from here to here. So this is the R vector basically. So this is the vector, and the angle between two vectors are always taken from tail to tail. So you know that if I will parallelly shift it, it will come something like that, and this will be the angle, this will be the same angle by corresponding angle. So this is the angle. So this is the angle between the vectors theta, let's say. Now we have to derive what is the value of R. Now we know that cos of 180 minus theta, this particular angle is cos of 180 minus theta, right? So this will be I don't know, I am doing it right way or wrong way, but yeah, a square, the magnitude of this will be a and this will be b, right? So a square plus b square minus r square by 2ab. Yep. So yeah, I am doing absolutely correct. So cos of 180 minus theta is nothing but in some other video I will explain why this happens, because I know the circular functions perfectly. But yeah, so cos of 180 minus theta is minus cos theta into 2ab is equal to a square plus b square minus r square. So it will finally come as a square plus b square plus 2ab cos theta is equal to r square. So what r is exactly here? R is the length of the resultant, right? So the magnitude of the resultant can be taken out from this formula. So there are several other formulas also, through parallel shifting of vectors I can make this a parallelogram and then tell you a formula about this. So there are several other formulas also, but and you may have done that in those formulas, but the point of telling this formula is it was unique to KIITJEE, and I got to know something new and I wanted to revise that. So yeah, I don't care about I don't care about you, I just want to revise myself. But yeah, so another way is a and b vector I do care about, right? Now you know I care about it. So make this vector a and join tail to tail. This will be the vector b. Now what will be the resultant? Resultant will be given by their this, because this is nothing but you have shifted, let me just label them, this is the resultant. You have just shifted the r vector from here to here, right? So this is just a shift, this is just the shifting of vectors. So just imagine this vector to be here and you will understand why this is r vector. So resultant will be given by the that of parallelogram. Now we will use Pythagoras theorem. So this is 90-degree triangle and the length of this will be equal to b. The length of this will be equal to, if this is angle theta, a vector and b vector के बीच का angle, this, if this is angle theta and then this will be theta, then this is b, then this will be b cos theta and this will be b sin theta. Now this complete triangle, this one, let me draw it with another color. This triangle, this complete triangle, use Pythagoras in this and you will find out the answer. Cos square theta plus sin square theta is equal to 1. Use that identity and you will finally get out the answer. So I know how to do that, so I won't do more than that. Now let us talk about how to find out the angle between vectors. One formula is very simple. Again, let me make the parallelogram thing. This is I don't like this mess. Better. So let us just complete the parallelogram. Okay, and then this will be the resultant. Now let us do everything. Let me just mark it. B vector, a vector, this is r vector. So let me mark these angles. This is theta, so this will be also theta, right? Now this was what? B sin theta, this was b cos theta. Now this angle is this. Now the angle between the resultant and the bottom vector, let's say this is alpha, then one most popular formula is just see this whole triangle, this one triangle whole, then you will find out that tan alpha is equal to b sin theta upon a plus b cos theta, right? But this is tan alpha, so tan inverse of alpha minus 1 alpha will be this thing. Oh, sorry, what I am doing, tan inverse of tan minus 1 of, I don't think I would have any viewer right now watching me, but if I would have, I will jump off. Okay, so tan inverse of b sin theta upon a plus b cos theta is equal to alpha, right? So this is how we find out the answer for these things. So as expected, I don't have anyone in my chat right now, but that's all. So this is the thing. Now this was the popular formula. Now let us redraw the triangle. This is this is R, this is A, this is B. Don't think this is 90 degree, and this is R vector, right? So angle between the resultant and V vector, this will be alpha, this will be theta. No, this will be 180 minus theta, sorry. This angle is theta. So yeah, this is alpha. Then I told you the sine rule. This is theta. Once again, this will be 180 minus theta. So sine alpha upon once again b is equal to sine r sine 180 minus theta, 180 minus theta by r. So yes, I was a bit nervous because I thought I am going in wrong direction, but it's absolutely correct. So sine inverse of so sine 180 minus theta is nothing but sine theta, again circular function. So just remember these formula. You will, if you are right now in class 11th and you have just started, so you can just wait for some time. You will get to know about this in your trigonometry chapter, class 11th only. But yeah, sine of 180 minus theta, sine alpha, so this is sine theta, so this will be b by r sine theta. So yeah, is equal to alpha. So this is the way to find out alpha. So we have covered the part. Now let us get back to unit vector. So any Cartesian frame like this can be made. So representation of vector is a thing in Cartesian plane. So every vectors, when we have to add and subtract the vectors, we have to use a convenient way rather than always doing the method of using resultant through a square, finding out resultant through a square plus b square plus 2ab cos theta and all of that. We have to use some simpler ways for when the vectors are more than 2, right? For vectors are more than 2 or even for 2 vectors you can use it. I find it more convenient in all cases, so yeah, you can use it. So any vector, like let's say this is a vector, let me use a different pen. Let's say this is a vector 5 meter. So you are saying nothing but that displacement. Let us take the example of displacement. Displacement from point origin to point A is 5 meter, right? You can also write it in vector form through two different vectors. Like if you will say that, if you would have said that uh, 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 let me do it for you now. Rather than writing it 5 meter in 37 degree 5 meter 37 degree north of east, I think you know that how we tell about the direction of a vector. So rather than saying this, we could have just said that particle have traveled, the displacements are in x direction it is equal to 4 meters, and in y direction it is equal to 3 meter. Vector in vector form, 3 meters plus 4 meters. So this is not the correct representation, but just for the sake of your understanding, I am saying all these things. So 3 meter plus 4 meter vector, when we will use vector form of addition, this will be equal to this, right? So rather than writing this, we can find out a unit vector in the direction of x. Actually, yeah. So we can write down a unit vector in direction of x and multiply it by 4, and a unit vector in direction of y and multiply it by 3, and write it as addition of 2. So the generalized vectors are I cap, j cap and k cap. I am moving a bit faster here because I was too much fundamental before that. I cap, j cap, k cap, and I is for x axis, j is for y axis, and k is for z axis. So in this form we can represent any two vectors. So there were some questions like just you can try it on your own. If two vectors are of equal magnitude and resultant is also of that own magnitude only, then find out the angle between the vectors. So let us say the magnitude of the vector is a, then a square plus 2 into a is a square cos theta is equal to resultant ka square, which is a square only. So a square will cancel out a square, it will come as cos theta is equal to minus 1 by 2, and this happens in which case cos is negative in the second quadrant and 1 by 2. So cos of which angle is 1 by 2, so 120 degrees. 120 degrees you will get this way. You can even remember that if two vectors are of equal magnitude and the resultant is also of equal magnitude, then the angle between them is 120 degrees. Then it's 90 degrees wala funda. If a magnitude of a plus b, a vector plus b vector, if it is equal to a minus b vector magnitude, directions can never be equal because b is just opposite. Then theta is equal to what? Theta will come out as 45 degree because a square plus b square will finally cancel out, and 2ab cos theta will become 4ab cos theta when you will shift it from one RHS to LHS. Then cos theta will come out to be 0, and that is why you will get answer. No, it will not be 45 degree, it will be 90 degree. I'm just coming back in 1 minute. yeah, I am back. Yes, so theta will be 90 degree in this case. Now I will speed up a little. So this was the thing. So what do you think is the maximum value of r? What is the maximum value of vector a plus vector b? Magnitude. What is the maximum magnitude? It will be simply the scalar addition of both a plus b, because cos theta revolves between 1 to -1, right? So when the cos theta will be plus 1, r will be equal to a plus b, a square plus b square plus 2ab cos theta will be r square, and r will be a plus b, positive a plus b. And if cos theta is 180 degrees, in that case it will come out to be a minus b, and that will be the least value, because cos theta least can be 180 degrees at 180 degrees, right? So yeah, that's the thing. So that is the maximum value of a plus b and a, and in the similar way it will be a minus b. You can all derive it on your own, and the maximum and minimum value will be come out to be that way only. So component of a vectors, let us talk about the component of a vector. So I guess where yes. So in here, in this example, the 5 meter can be written in the form of 3 meter and 4 meter, right? So what are these 3 meters and 4 meters? These are the components of 5. The vector if a vector is written in the form of multiplication of the magnitude of its 90 degree, like let's go and let's start it from scratch. So I think I won't be able to continue today's live, but I will make it live tomorrow. So thank you, bye bye. I know